These are the frequently asked questions for pre-calculus for section 2.6, day 2. Starting with number 25, we have find the asymptotes and intercepts of the function and graph the function. So for 25, h of x is 2 over x cubed minus x. The first thing to do with this would be exactly like we did in class, factor what we can factor. So if you take that x out on the bottom, a common monomial factor, you notice, wait a minute, now I have a difference of 2 squares down there. So that'll be x plus 1 times x minus 1. And we're going to get all kinds of information from what we see there. So they wanted the asymptotes. And this is usually the way I'll start, is I'll say, well, what numbers are out? You know, what do I have in my denominator that would make me divide by 0? Well, this time we have x equals 0, and I better give myself some more room, because we also have x equals negative 1 and x equals 1 that would give us a 0 in our denominator. Horizontal asymptotes. Well, horizontal asymptotes, remember, we have to think about the fact that this would be infinity cubed down here, minus infinity. And as the numbers get larger and larger, that's going to get closer and closer to 0. So y equals 0 is going to be our horizontal asymptote. Then we need x and y intercepts. And the x-intercepts come from making our making our numerator equal to 0. But it's a 2, and we don't have any rules in math that will make us magically change a 2 into 0, so we don't get one. There is no x-intercept. We just put none and walk away from it. And then the y-intercept is what we get if we put a 0 in for x, because this is always 0 something, but look at our vertical asymptote, x equals 0. We can't use that. We don't get one of those either. So this one apparently does not cross the x or the y axis. Now let's go ahead and get the information that we have on here, and then we can figure out some numbers to put in on this graph. So we have vertical asymptotes at 0, 1, and negative 1. And then we have the horizontal asymptote at y equals 0. All right, we have everything there. So now what we would want to do is make tables for each segment that we see here. And sometimes I will start over here in this right-hand corner just to see which of these two this is going to go in. But it doesn't make any difference which region you go into. It's just a matter of making sure that you have that original function, whether or not you want to do 2 over x cubed minus x, or if you want to use the red version here, makes absolutely no difference. So go ahead and start putting some numbers in. And let's see, over on this side, since my asymptote was negative 1, I try negative 2 and negative 3 and see what I get. So if we take that negative 2 and put it back in the original, we'll obviously have a 2 on the top. But then we have a choice here of whether or not we want to use the factored form, or if we just want to keep going with this basic right here. Either way, it doesn't make any difference. So we have the 2, and then we have negative 2 cubed, which is negative 8, and then we have that minus 2. So that's going to give us 2 over negative 10, which is going to give us a negative 1/5. And then we could put a 3 in there. And if we put a 3 in, I'm going to try and show as much math here as I can, since you obviously had a little trouble with this one. With the 3, we would have a 2 over, and then we'd have negative 27 minus 3. And that would give us 2 over negative 30, which would be a negative 1/15. All right, so let's see what that tells us about our graph. At negative 2, we have a negative 1/5. And then at negative 3, it's getting closer. So that means this branch is going to hug those asymptotes like so. So now really that's going to help me out a lot, because usually in this situation where we have basically vertically this is separated into 4 different sections, this branch is probably going to go up here. But again, you could always make a table to figure that part out. So now let's do that. Put a 2 and a 3 in and see what we get. So now if we put a 2 in, we have 2 on top, and then 2 cubed is 8 minus 2. So that's going to give us 2 over 6, which is 1/3. And then we go ahead and put a negative 3 in, so 2 over, oh, I'm sorry, not negative 3, positive 3. 27 minus 3, which is 2 over 24, or 1/12. So 2, 1/3, 3, 1/12. It's getting closer and closer, and like I said, we already knew what was going to happen here anyway. If you graph enough hyperbolas, then you just notice that that's what tends to happen each time. All right, so what's left? What's left is we want to know what's happening in between 0 and -1 and 0 and 1. And that, of course, is going to require some fractions. I mean, that's what we would have to do. So for these, I don't know, I suppose if you don't feel incredibly comfortable with doing that math in your head with the fractions, you could probably just grab a calculator to do the math portion of this. Otherwise, we have been using it to find the extremes anyway, so the least you could do is use it to figure out where your lowest point is for your graph and where your highest point is. So at this point, you would probably punch it into your calculator and say, we need 2 divided by x cubed minus x. And then we would go ahead and graph that, hoping to see these other pieces. And we're going to see a branch up here and another branch down here. And we would need to know where is that lowest point and where is that highest point. So I'm going to find those and then start this back up. The 2 points that I have here for the lowest and the highest point, the lowest point from 0 to -1 is going to be a -0.577, so about halfway, a little bit more than that, and then 5.196, so right about there, and we have a very thin U shape going on. And then the other one is 0.577, so we see that symmetry, -5.196. About there. And there is the symmetry. Again, if we're going to do this completely and totally by hand, then what we would want to do is make a table and put in -3/4, -1/2, -1/4, and see what we get to go through all of that process. But we won't be able to find that lowest point, that local min, without the use of the calculator, and we won't be able to find this local max at this point without the calculator. But we could make a pretty good sketch, you know, based on what we would see from our fractions for number 25. Number 27. 27 says find the asymptotes and intercepts of the function and then graph the function. So for number 27, we have 2x squared plus x minus 2 over x squared minus 1. And what we want to see is, well, is this factorable? And if it is, you know, can we go ahead and do the factoring? The good news is that our denominator is factorable. That is a difference of 2 squares. So that's x plus 1 and x minus 1. Now, 2x squared plus x minus 2, I'm sure because you asked about this one, you spent some time trying to factor that and you realized I can't. 2x squared plus x minus 2 is not factorable. Now, the first way to tell that is by finding the discriminant, which would be 1 squared minus 4 times 2 times -2, and realizing that's not going to be a perfect square because this will be 1 plus 16, which is 17. And when that discriminant is not a perfect square, that means it's not factorable with integer coefficients. So now what we need to do is realize there probably are some zeros there, and we're going to need those as we go through and do all of our graphing. So I want to know, when does 2x squared plus x minus 2 equal 0? Well, we could go ahead and complete the square, and that would get it for us. So move the negative 2 out of the way, and then divide everything by 2. Because remember, when you want to complete the square, you have to have a 1. There's a little bug flying around. You have to have a 1 in front of your x squared term. So let's see here. We're going to divide that also by 2. So x squared plus 1/2 x. And then we have equals 1. So now we would take the 1/2 and divide it by 2 and make it 1/4. And then we'd square that, and that would give us 1/16. So this is x plus 1/4 squared, b over 2, so 1/2 divided by 2 is 1/4, equals, well, 16 over 16 is 1, so this will be 17/16. Then x plus 1/4 equals plus or minus the square root of 17 over 4 by taking the square root, and x will equal negative 1/4 plus or minus the square root of 17 over 4. So we have 2 of them there that we would just go ahead and punch into the calculator. So let's go back and start talking about the asymptotes. Vertical asymptotes come from the denominator equaling 0, so x equals 1 and x equals negative 1, not necessarily in that order. Horizontal asymptotes, well, the degrees are the same. So if we have infinity squared and infinity squared here, that's going to drop out and we're going to be left with y equals 2 because there's a 2 in front of there. So there's our horizontal asymptote. Now, our 2 x-intercepts, remember our x-intercepts are going to come from something 0. And that's what we're trying to find when we are solving, and that I had to do by completing the square. So you take negative 1/4 plus the square root of 17 over 4, and negative 1/4 minus the square root of 17 over 4. And that gives us 0.7810. Remember, we're just trying to find that number that's going to work. Negative 1.2810. And then the y-intercept is found much easier and faster by just going ahead and putting a 0 back in for x everywhere that we see one. Whether or not you do that in the original or the factored form makes no difference. But 0, 0, negative 2, 0 minus 1, negative 1, that's going to give us 2. So y equals 2. All right, let's see if we have everything. We have vertical asymptotes, horizontal asymptotes, we have x-intercepts, we have y-intercepts. So it's time to get busy with the graphing. So let's get all of this in there. We said the vertical asymptotes were at 1 and negative 1. And then we had a horizontal asymptote at y equals 2. And then we had some intercepts that we could graph. We had 0, 2, and then we had 0.78, well actually it was the other way around, 0.7810, and we had negative 1.280. Now that's really helpful, because what I know now is this branch has to go this way, has to go that way, so I can get the sketch of that in there. And we want to see what the middle is doing, because that will tell us where the other branch is going to go. Whether or not we have kind of an S-curve in the middle, or if we end up with a parabola, actually tells us what we need to do here. So I'm going to need another point. So what I would probably try is negative 1/2. And see what I get. So we go ahead and just punch that back in, and I'm going to take a second, and you could certainly do it by hand if you want to, but I'm guessing most people aren't going to. I'll be right back with that one. 1/2 gives us 2 2/3. So we are seeing an S shape in the middle, snake-like curve, and that absolutely tells me my other branch is going to go like so. Now, if you don't know that, remember you can just take a point and put it in, take something like 2 and go back through and see what you get. 2 gets you 2 2/3. So 2, 2 2/3 is right there. And again, you know that that's going to go right along those asymptotes. So 27 is done. This has been nothing but interruptions as I try to do these 20 minutes later and I have 2 graphs done. So with this one, we have accomplished everything that they wanted us to do with number 27, and I will move on to number 28. Number 28 says, find the asymptotes, intercepts of the function, graph the function. That's the same thing we were doing on the last page. So with number 28, what we'd want to do is take a look at our numerator and denominator. And I think I'm going to put that up here. And pretty obviously we can factor the denominator. But the numerator, I'm not quite sure. You know, I'll pull a negative out of that. And then you could certainly try a couple of things. But remember, we can always do b squared minus 4ac and figure out whether or not we're going to be able to factor this. This one, it's not factorable. It's not factorable. I'm going to need a little more space over here, and I will just start over and complete the square. So first thing we want to do is move that 12 over, so subtract 12, then divide everything by -3, and we will get x squared minus 1/3 x equals 4. Next thing is our b over 2 squared. So 1/3 divided by 2 is the same thing as 1/3 times 1/2, which would be 1/6, negative 1/6. And then we'd square it, and we would add 1/36 to both sides. So now this becomes x minus b over 2, negative 1/3 times 1/2 is 1/6 squared equals 4 plus 136, which is 145/36. Square root both sides, so x minus 1/6 equals plus or minus the square root of 145 over 36, square root of 36, which is 6. And I'm already running out of space again. And x will equal 1/6 plus or minus, because we got to add the 1/6 to both sides, the square root of 145 over 6. So again, it's not factorable, but that doesn't mean we can't find the zeros, and I just wanted to get all of that out of the way right away. All right, so now let's go back, find the things they wanted us to use here, and that would be vertical asymptotes. Well, factoring the denominator was not a problem. Factoring our denominator here was x plus 2 and x minus 2. So that means x equals 2 and x equals negative 2 become our vertical asymptotes. Horizontal asymptotes, well, that's about degree. And the degree of the numerator was equal to the degree of the denominator. So if we have infinity squared up here and infinity squared down here, those are going to cancel out, and that'll leave us with -3. So y equals -3 is going to be our horizontal asymptote. And the reason that I went to all that trouble of completing the square was so that we could figure out what our x-intercepts are pretty easily. So for our x-intercepts, we would punch in 1/6 plus the square root of 145 over 6 and 1/6 minus the square root of 145 over 6. Those come out to 2.1740 and negative 1.8400. And then the y-intercept, remember that's plugging a 0 back into either the original or the factored form, but we couldn't factor the final thing anyway, so we go ahead and put a 0 in here. Well, those will all be zeros because they contain multiplication by the x piece. So 12 divided by -4, that will give us -3. So 0, -3 is our y-intercept. Now we know a lot about this graph before we start, so we want to go ahead and get all of those pieces of information onto our graph. And we had vertical asymptotes at x equals -2, x equals 2. That was our denominator equaling 0. And then looking at what would happen with infinity gave us a -3 for y equals -3, our horizontal asymptotes. And then we did actually get some points. We actually had 3 of those that we could look at, and that is 0, -3, which of course, you know, we understand at this point you can cross a horizontal asymptote for a portion of the graph. That's going to happen here. And then we had 2.1740 and -1.840. All right. So now we want to start thinking about what's going to happen, and this one I'm going to do a little bit differently than I did the last one, and then I'm going to use some logic here. Now, we have a choice in this middle portion of the graph about whether or not we believe that's going to be parabolic or it's going to be an S-shaped curve. And right now, looking at what I have, I know this has to be an S-shaped curve. Here's how I know. There are no more x-intercepts. So this, given this point, right here, and this point has to be an S-shaped curve that does this. Now, pretty obviously, we could put a 1 into the function and we could get a better picture of just how low that's going to be at 1. But depending on what we're going to use this for, if we're going to use this for limits, that's enough information. But it certainly wouldn't hurt to tack a 1 in there and see exactly what it's going to do. So if we put a 1 into the function, we'll get -3 times 1 is -3. -3 plus 1 is -2. -2 plus 12 is 10. And then 1 squared is 1, and -4, that's going to give us -3 1/3. So 1, 2, 3, and I'm off by a little bit here. This swings a little bit wider at this point. But again, depending on what we need it for, if we just need a sketch to get the limits, we would have been just fine. So now, what I need to know is my branches. And again, we do already know that because we do have a point here that crosses. So this branch is going to go this way. Now, if you're struggling with, okay, should I put the branch up on the top or on the bottom? Once we do enough of these, we realize it's going to be down here. But if you don't, then you continue on with that table and you say, all right, I'm going to plug a -3 in there and see what happens. And when you plug a -3 in there, you really don't even have to pay a lot of attention to what you're putting in as long as you can figure out that it's going to be -3 and then something that's negative below that. So you could certainly put that back in, and we'll have -3 times 9 is -27. -27 minus 3 is -30, so -18, and then -3 squared would be 9, and 9 minus 4 is 5. And that's going to give us a -3 3/5. So 1, 2, 3 3/5. And of course, we know that those asymptotes are going to work for those branches, and so that will take us in there. And knowing that it goes in that close might tell me, you know what, maybe I should put a 3 in there. Exactly how close that goes in on the corner. If it's a test question, absolutely we're going to do that. So we put the 3 in, and we get -3 times 9, which is -27. And then we have plus 3, and that's going to give us -24. -24 plus 12 will be -12. And then if we put our 3 in the bottom, we have 9 minus 4, which is 5. So -2 and 2/5. So I wasn't that far off anyway with this corner spot. But for a test, you want to be a little more particular. You want to get those points that are close into where your asymptotes cross so that you can find all of those. Now, I hope you're wondering, what I'm wondering is, what about those slant asymptotes? You know, when on earth do we use those? Well, the degree of the numerator has to be greater than the degree of the denominator, and that's why in 29 and 30 we're going to have to figure out what's going on with the slant asymptotes. So first things first with 29, we try to factor good old x squared minus 2x plus 3 plus 2 doesn't require any factoring. And we try to think of two numbers that multiply to positive 3 and add to negative 2, and isn't going to happen. So the next thing we would try is completing the square. So I'm going to move that 3 over to the other side, and then we'd go ahead and complete the square by b over 2 squared. Well, we'd add 1 to both sides, and that would give us x minus 1, the quantity squared, because 2 divided by 2, negative 2 divided by 2 is negative 1, and when you square it, you get 1. And that'll give us negative 2, and buzzer sounds again. That's going to be imaginary when we take the square root of that. So we don't get a 0 in the numerator. It is not going to happen. So let's start going after what we do have. Vertical asymptotes come from that denominator equaling 0. Horizontal asymptotes, well, that's all about the powers. And we see here that we would have infinity squared over infinity, and so that's going to go on forever. So we don't get one when the degree of the numerator is greater than the degree of the denominator. That's just going to keep going. So there's another piece of information we have to do without. X-intercepts, that was that trying to complete the square up there. That's not going to work. We don't get any. There is no way to make that numerator a 0 in the real number system. Y-intercepts, that's just shoving a 0 back in for any x that we see. So these would be zeros, and we'd get 3 halves. So that one is going to be 0, 3 halves. So a little piece of information, not a lot, but we go with what we have. And then we would want to know, where is that slant asymptote? So talking about the slant asymptote means that we have to do that division to figure out what's going on. So we have x squared minus 2x plus 3. And we actually want to see, what does that division give us when we divide by x plus 2? So remember that with this long division piece, all we're trying to do is match up that first term. X times x plus 2 will give us x squared plus 2x. That is working, so we put our x up here. We change the signs, and we add. Our x squareds are gone. Now we have a negative 4x, and we bring down the 3. X plus 2, we need a negative 4 out here. So negative 4x minus 8. That negative 4 is doing its job. And then we'd go ahead and change the signs and add, and we'd get 11, which just happens to be our remainder. But we don't care much about the remainder. What we care about is this, because that is our slant asymptote. Our slant asymptote happens to be y equals x minus 4. And that's an additional piece of information that we want to use as we are graphing. So we've got a vertical asymptote at x equals negative 2. We don't have a horizontal asymptote. We don't get an x-intercept. We do have a y-intercept at 0, 1, and a half. And we do have a slant asymptote of y equals x minus 4. Now remember, this is y equals mx plus b. So b is negative 4, and our slope is going to be just 1 over 1. So we're going down to negative 4's, 0, negative 4. And then we're going to go up 1 and over 1. And that will give us our slant asymptote. All right, so looking kind of strange. And what that tells me is this is probably a hyperbola that has a couple of funky branches that are doing this type of thing. So I'd want to know where. You know, what are the points that I can get out of this? So we go back to 29 with the understanding that we need to get some points in the negative 1. We have 0, but negative 1 and maybe 1 range. And see what we get. So negative 1 squared is 1. Minus 2 times negative 1 is really plus 2. Plus 3, that's going to give me 6 over. And then we'd have negative 1 plus 2, which is going to give us 1. So negative 1, 6 is a good point. And you can see it's doing that branch business that we knew was going to happen as we went through this. So let's put a 1 in there and see what happens. We'll get 1 minus 2 plus 3. So 1 minus 2 is negative 1. Negative 1 plus 3 is 2. Over, and then 1 plus 2 is 3. So 1 2/3. Now, again, I don't know how close that's going to go into the corner, but we're getting a good idea of what's going on with this, so maybe we try a 2 as well. 2 squared is 4. Minus 2 times 2 is minus 4, plus 3, so we're going to have a 3. And then 2 plus 2 is 4, so 2 3/4. So it is starting to go back up. My one concern here would be if I'm graphing this on the test, I want to know that lowest point in this region. That's what I want to know. And so we grab a calculator and get that point. I'm going to pause this and get that point for you, and then we'll continue on. Things that occurred to me while I was punching this in is some of you might be having trouble finding that local max and that local min, because when you graph it, you get something that looks totally different. And that's because you're not putting parentheses around the numerator and the denominator. You have to, or your graphing calculator just follows the order of operations. So all it's really going to be dividing is the 3 by the x. Because you need those parentheses, you have to group those together. Secondly, on this one you have to do a little window tweaking in order to get your second one, which is your local max. But your local min here on number 29 ends up being 1.317, 0.633. So we go 1 and a little bit further, and then up to that 0.633, which is about there. And that gets you your branch. And remember, that slant asymptote is an asymptote. We need to approach that, but never cross over it. So now we know that there's going to be another branch. That's just how hyperbolas work. And what we'll need to do is get some points down where we know that's going to be, basically in this V position over here. And that might go off of my negative 10 to 10 grid a little bit, but we'll see what happens. So what we have to do is just find some points down there, and our asymptote was at negative 2, so maybe we'd try something like a negative 3 and a negative 4 and see what we get. So negative 3 squared would be 9, negative 2 times negative 3 would be 6 plus 3, so we get 18 for our numerator, and then negative 3 plus 2 will be negative 1, so that will give us negative 18. So yeah, that's considerably below what we have graphed here, probably somewhere around there. Putting a negative 4 in, we would get 16 plus 8 plus 3, so 27, and then negative 4 plus 2 is negative 2, so negative 27 halves. So negative 13 and a half. So now we know where this is going to go. Again, we know that we have that slant asymptote over here, and we know that this is going to come in and curve at that asymptote. So what we would need to know is, where is that highest point? And for this one, I actually had to change my window to trick the graphing calculator into allowing me to go down there. I had to change my y values from negative 20 to negative 10 in order to see that piece. So that might have been something that you guys were struggling with when you were doing this. So that one ends up at negative 0.5, negative 5.317, negative 12.633. So a little higher than what we had at that negative 4 position. So negative 5, 1, 2, 3, 4, 5, and 12 and a half, about right there. And then we have our 2 branches. So again, try not to use the table feature. We're not using this for the table feature. We're using this just for those max and mins. So don't use those graphing features. That's something that's going to be taken away when you get to AP Calc. Number 30, we have find the asymptotes and intercepts of the function and graph the function just like all the rest. And this one, the degree of the numerator is greater than the degree of the denominator. So we're going to have a slant asymptote. So we have x squared minus 3x minus 7 over x plus 3. And the hope is, of course, that we can factor our numerator. Unfortunately, once again, we can't do that. But I'm hoping that perhaps there's some x-intercepts anyway, so I'll add 7 to both sides and complete the square. Negative 3 divided by 2 is negative 3 halves, and when you square that, you get 9 fourths. So this will be x minus 3 halves squared, and then we're just going to have to do a little converting here and get our nice little 7 in fourths. So 28 fourths plus 9 fourths, that's going to give us 37 fourths. So we'd take the square root, x minus 3 halves equals plus or minus the square root of 37 over 2, and then add the 3 halves, so 3 halves plus or minus the square root of 37 over 2. Again, not necessarily something I needed immediately, but I know I'm going to have to do it, so I'm going to get it out of the way while I'm thinking about it. Vertical asymptotes. Denominator is 0 at x equals negative 3. Horizontal asymptotes. Well, this is infinity squared and this is infinity, and if we cancel out one of those infinities, we still get infinity, so we're not getting one. There is no horizontal asymptote. Now we go after the x-intercepts. And for that, we probably wouldn't want to leave it in fraction form. We're going to graph this. So we grab a calculator and punch in 3 halves plus the square root of 37 over 2 and 3 halves minus the square root of 37 over 2. Those come out to 4.5410 and negative 1.5410. Y-intercept, much easier. All we have to do is plug zeros in here, and wherever there's an x, there's a 0, so negative 7/3. So to find the x-intercepts, you're making y equal to 0. To find the y-intercepts, you're making x equal to 0. That's a lot of good information, but we don't have the slant asymptote yet. And that was so helpful in the last problem, being able to know where we can aim at. So x squared minus 3x minus 7 is going to be divided by x plus 3. Our little x plus 3 is going to need to be multiplied by x to get rid of that first term of x squared. And since it's working, I'm going to put my x up here. I'm going to change the signs and I'm going to add. Then I bring down that negative 7. I have my x plus 3. I need to multiply that by a negative 6. That will give me negative 6x minus 18. It's going to do its job, so I'm going to put that negative 6 up here and then change the signs and add, and that leaves me with 11 for a remainder. But we don't really care about what we have as a remainder there. This is what we needed, and that was our slant asymptote. That's going to save us some work. Y equals x minus 6. So let's get all the information on here that we have up to this point, and that would be a vertical asymptote at x equals negative 3. And we didn't get a horizontal asymptote, but we do have a slant asymptote of y equals x minus 6. So remember, the b value is negative 6. And our slope is 1 over 1, so 1, 2, 3, 4, 5, 6, up 1 over 1. Now the reason that I'm continuing on over in that left-hand corner over there is because pretty obviously this is another branch hyperbola. And it's just a matter of figuring out where those branches are going to take place. And that's what happens when we're dealing with that slant asymptote. That gives that away for us. Now let's put the points on there that we do know. We had an x-intercept at 4.541, 0. And we had one at negative 1.541, 0. So we're going to do something like this. I just have to figure out what. And then we had one more piece here. Let's see, 0, negative 7/3. So 0 and negative 7/3. Like so. So we're not guaranteed anything beyond those zeros that we had. And I'm not guaranteed that my point of 0, -7/3, my y-intercept, that that's the lowest point. I just don't know that yet. So we're going to have to find that max and min again. I'm going to pause this while I get that information for you. With the help of that second minimum feature, second trace, number 3 minimum feature on your graphing calculator, the lowest point for the upper branch here is 0.317 and -2.367. So a little bit to the right of 0, and then -2 and 2.3. So this is what's going on with that upper branch. And now we need to know what's going on with the lower branch, and since I was already busy finding that max, that minimum for that piece, I found the max for this one. So the local max down here was at -6.317, -15.633, which of course is off our grid here. Probably about there or so. And we know this is going to go along with those asymptotes. We have that nice slant asymptote, and we could certainly extend both of those. And then just find a couple of points. That was -6.317, so maybe try -7 and -8 in there and see what we get. You go back to that original and you punch those in so that you can see what is a -7 and a -8 going to give you. And since I've already gone through a couple of those before, I'm going to go ahead and just give you a quick little table here of -7 at -15.75, and then -8 is at -16.2, and you'll use that to see how close everything is going to be. So this one ends up looking like so. So that slant asymptote comes in very handy. We do that whenever we have the degree of the numerator being greater than the degree of the denominator for our hyperbolas. That is finally done.